Good day, kids. You are welcome to Top Form Education Associates. My name is Olubayo Marilyn Kehinde and I'm your mathematics teacher. And today we are going to be continuing from where we stopped last week. We are going to be under the topic angles, measurement. Now to what we have today. Our lesson objectives. By the end of this lesson, you should be able to classify and name angles. You should be able to understand angles as a measure of rotation. You should be able to find the relationship between degrees, minutes, seconds, and revolutions. Remember, we said a complete revolution is 360 degrees. A complete revolution can be a full turn or a rotation. And finally, by the end of this lesson, you would be able to measure and construct angles using a protractor. So, for this lesson, we are going to be making use of a protractor. Alright, very quickly, we are going to be looking at the relationships between degrees, minutes, and seconds. Okay? Now, 60 minutes is equal to 1 degree. 60 minutes is the same as 1 degree. Okay, which means we have 60 degrees. Okay, are we following? We have 60 degrees we have 60 degrees in 60 minutes. We have 60 degrees in 60 minutes. Likewise, 60 seconds or 60 seconds, this is the symbol for seconds, is equal to 1 minute. Alright? Now, you can express an angle given in degrees and parts of degrees, minutes, and seconds as shown in the examples below. That means an angle can be expressed in degrees and parts of degrees, minutes, and seconds. Very quickly, we'll be taking some examples. The first one, A, says, convert 50.4829 degrees to degrees minutes. Okay, to degrees, minutes, and seconds. B says, change 46 degrees, 15 minutes. Remember, this is a symbol for minutes. Alright? While this is a symbol for second. So, change 46 degrees, 15 minutes to degrees and decimals of a degree. Okay, let's look at the solution to this question together. Solution. To get the minutes parts, we are going to multiply the degrees and decimal parts by 60. Okay, this is the decimal part of this degree. Alright? So, we're going to multiply 0.4829 degree times 60. Now, 0.4829 degree is the same thing as 0.4829. Alright? And when we do the sum, we're going to get 28.974 minutes. Remember, this is a symbol for minutes. Alright, therefore, 50.4829 degree is equal to 50 degree, 28.974 minutes. Alright? Now, to get the seconds part, remember we're trying to convert this to degrees, minutes, and seconds. Okay? Now, to get the seconds, we are going to multiply the minutes decimal parts by 60 to obtain the seconds. This is the minutes decimal parts. Alright? So when we do the sums, we are going to get 58.44 seconds, which can be approximated to 58 seconds. So 50.4829 will give us 50 degrees, 28 minutes, and 58 seconds. Alright, I hope we are following. By the time we summed all this, we've done all the calculation, we got 50 degrees, 28 minutes, and 58 seconds. Now, our second example. In our second example, we're asked to change 46 degrees, 15 minutes to degrees and decimals of a degree. We're trying to convert this to degrees and decimals of a degree. Now, to convert it, we first of all change 15 minutes to degrees. Alright? We are going to convert 15 minutes to degrees. Now, we all know that 60 minutes is equal to 1 degree. Alright? 60 minutes is equal to 1 degree. Therefore, 1 minute, are we following? 1 minute will be equal to 1 over 60 degrees. Alright? 1 minute is equal to 1 over 60 degrees, which we can translate to 15 minutes will give us 15 over 60 degrees. Now, when we do the sum, we have 0.25 degrees. Alright? Now, when we add it, we're going to have 46.25 degrees. So we have successfully converted this to decimals of a degree. Do we understand? We have successfully converted 46 degrees 15 minutes to decimals of a degree, which is 46.25 degrees. Alternatively, if you want to make your work easier, if you don't want to go through all the stressful process of writing all this out, you can reduce the working above, as 60 minutes will give us 1 degree. Therefore, 46 whole number 15 over 60. Very short method. You are going to have the same answer, which is 46.25 degrees. Now, we have another example here. This is simply addition and subtraction of degrees, minutes, and seconds. All right? We're going to be learning how to add and how to subtract degrees, minutes, and seconds. The first one, A, we are asked to add 10 degrees, 38 minutes, and 49 seconds with 8 degrees, 49 minutes, and 57 seconds. Now, B wants us to subtract 9 degrees, 39 minutes, and 48 seconds from 12 degrees, 27 minutes, and 40 seconds. Now, to do this, we are asked to add 10 degrees, 39 minutes, and 49 seconds to 8 degrees, 49 minutes, and 57 seconds. Now, when we add 49 seconds plus 57 seconds, we have 106. We have 106. But then again, 60 degrees is equal to 1 minute. Okay? So, we are going to subtract 60 from 106. Now, when we do that, we are going to get 46. Alright? So, we have 1 minute and 46 seconds. Alright? Remember I said 60 degrees is equal to 1 minute. So we can't write 106 here. Instead, we subtract 60 from 106. So we have 46. Therefore, we have 1 minute 46 seconds. Hence our 46 here. Do we understand? Now, this one left behind, this 1 minute here, we're going to move it to the minutes column. Alright, now when we do that, we're going to add everything. We're going to add 1 minute plus 38 minutes plus 49 minutes. Now, when we add it, we have the sum of 88 minutes. Remember again that 1 degree is equal to 60 minutes. So 60 minutes is equal to 1 degree. So we can't write 88 here. We're going to subtract 60 from 88 minutes. Alright, now when we do that, we are going to have 28 minutes. Okay, so therefore we have 1 degree, 28 minutes. Alright, now we can't, the reason why we did not write 88 here on the minutes column is because 88 minutes is greater than 60, and we have just 60 minutes in 1 degree. Hence, we subtracted 60 from 88 minutes, giving us 28 minutes. So we have a sum of 1 degree, 28 minutes. Now, this 1 degree we have here, we're going to carry it over to the degrees column. Alright, we're going to carry it to the degrees column. Now, when we add it, we're going to add 1 degree plus 10 degrees, okay, plus 8 degrees. Now, when we do that, we're going to get a sum of 19 degrees. Hence, our answer is 19 degrees, 28 minutes, and 46 seconds. I hope you understand that. Now, the B part asks us to subtract 9 degrees, 39 minutes, and 48 seconds from 12 degrees, 27 minutes, and 40 seconds. Now, to do that, we are going to try to subtract 48 minutes from 40 seconds. We all know that's not possible. So we are going to borrow 1 minute from the minutes column. Remember that 60 seconds make 1 minute. So we are going to borrow 1 minute, which will give us 60 seconds from the minutes column. Now when we add that to this 40 here, we have 100 seconds. Now we can subtract 48. So 100 minus 48 will give us 52 seconds. Okay, so we have 52 seconds here. Now for this column, remember that we are now left with 26 minutes because we borrowed 1 from here. Okay, so we have 26 minutes left here. Now once again, 26 minutes cannot subtract 39 minutes. So we are also going to borrow 1 degree or 60 minutes from the degrees column. All right, now when we add that, we are going to get 86 minutes. Now we can subtract 39 from 86 minutes, which will give us this 47 minutes we have here. Now we have just 11 degrees left. Now when we subtract 11 degrees minus 9 degrees, we have 2. So the sum of this subtraction is 2 degrees, 47 minutes and 52 seconds. I hope we are following, students. Now we are going to move on to the types of angles. All right, number 1, we have an acute angle. An acute angle is an angle which is less than 90. All right, any angle which is less than 90 is known as an acute angle. This is an example of an acute angle. As you can see, the above diagram XYZ is an acute angle because it is less than 90. Examples of acute angles are 1 degree, 40 degrees, 45 degrees, 50 degrees, 70 degrees, 89 degrees, and so forth. As long as it is less than 90, it is an acute angle. Now, number 2, we have obtuse angle. All right, an obtuse angle is an angle which is greater than 90. Pay attention, it is greater than 90, but it's less than 180. All right, it is not more than 180, it is actually lesser than 180. Now, this is an obtuse angle, an angle which is greater than 90 but less than 180. Now, in the diagram above, XYZ is an obtuse angle because it is greater than 90 but less than 180 degrees. Examples of obtuse angles are 91 degrees, 100 degrees, 130 degrees, 179 degrees, and so on and so forth, but not more than one. They are not up to 180. So as long as they are not up to 180, it is an obtuse angle. All right, reflex angles. A reflex angle is an angle which is greater than 180 degrees but less than 360 degrees. So a reflex angle can be more than 180 but it's not up to 360 degrees. In the diagram above, these angles are reflex angles. They are all reflex angles because they are not up to 360 degrees, but they are greater than 180 degrees. Examples are stated below: 181 degrees, 200 degrees, 270 degrees, 359 degrees are all examples of reflex angles. Now, we have right angle. All right, now a right angle is an angle that is equal to 90 degrees. Okay, 90 degrees is a right angle. This is an example of a right angle. A right angle is a quarter of a turn. Remember, we said a full turn is 360, half is 180, then quarter is 90 degrees. So a quarter of a full turn or a full revolution is a right angle. Do you understand that? A right angle is an angle that is equal to 90 degrees. Okay, very quickly, we are going to move on to measuring and drawing of angles. Remember, when I was starting this lecture, I said you need your mathematical set because we're going to be making use of the protractor. A mathematical instrument used for measuring and drawing angles is called a protractor. All All right, a protractor is a mathematical instrument used for measuring and drawing angles. Okay, now a protractor can be circular, which is 360 degrees, or semicircular in shape, that is 180 degrees as shown below. A protractor can be full 360 degrees or semicircular in shape, that is 180 degrees. The one we're going to be making use of in the course of this study is a semicircular protractor. See, this is an example of a protractor. This is also an example of a protractor. All right, these are protractors. This point here is called the center point. We also have it here. This is the center point of this protractor. It is called a center point. Okay, this is the center point. Now, this line we have here, is called the baseline or the zero line. Are we following? This is the baseline, or we can also call it the zero line. Here, where is our baseline? This is our baseline. All right, this is our baseline or zero line, and this is our center point. Now, in a protractor, we have inside scale to measure anti-clockwise rotation and outside scale to measure the clockwise rotation, meaning inside measures anti-clockwise, all right, while outside measures clockwise. Here, this is our inside scale to measure anti-clockwise rotation. Okay, this is our inside scale to measure anti-clockwise rotation, while this is the outside scale to measure clockwise rotation. Okay, I hope you understand that. Now, quickly, let's take some examples with our protractor. Now, we are asked to measure this angle AOB with our protractor. All right, so we are asked to measure this angle. This is angle AOB. We are asked to measure the angle with our protractor. Now, to do this, we are going to place the center point. Remember, I said this is the center point. All right, this is the center point of the protractor. We are going to place the center point at O. All right, we are going to place it at O, point O of the angle. Remember, this point is called the vertex from previous study. This point is called the vertex, where the two arms of the angles meet. Is called the vertex. So we're going to place the center point at O in such a way that the zero line of the protractor coincides with the line O and A of the angle. All right. Now, the second point here, we're going to count round the numbers from point A until we reach point B. Okay, now we're going to the third one, and the final one says we're going to read off the measurement from the inner scale to get our answer. Now let's do this. First of all, this is our angle AOB. Okay, this is our angle AOB. Now we're going to place our protractor on the center point where we have 0 on the vertex. We've just placed our protractor here, and it coincides with line A and O. All right. Now, the next thing to do is to read from the inner scale. All right, from line A to line B. And when we do that, when we count from this inner scale, we are reading anti-clockwise now. Okay, we are going to have 137. This is 135 degrees. So we have 136 and 137, meaning this angle is 137 degrees. Do you understand? This is angle AOB is 137 degrees. Very good. Now, example 2 asks us to draw angle 110 using our protractor. Okay, this should be easy. The solution, let's take out the guidelines. We are asked the solution, the guidelines number 1, we have to draw a straight line with our ruler. Okay, we take out a straight line, then we select a suitable point, any point where you want the vertex of your angle to be, and you name it point O. So we will take a straight line, then we'll take any suitable point we like. So I've got my point here, and we label it O, and we place the protractor on the center of the vertex point, remember, and let the baseline or the zero line coincide with the straight line we have drawn. Then we'll mark the angle which we are asked to draw with a pencil, and we'll get it. Now let's practicalize it. Okay, now this is our straight line. We have drawn our straight line, and we have marked where we want the vertex of our angle to be, and we have named it point O. Okay, now next we are going to put our protractor on the straight line we have drawn and make sure that the center point coincides with the vertex, coincides with O, which we have marked. Now we are going to mark our angle. Okay, this is 110 degrees. We are asked to measure 110 degrees, so we are going to put our point right here, put a dot here. Okay, we are going to mark our work. So we have successfully marked our 110 degrees. All right, now when we remove our protractor, this is the angle we have. Do we see it? Do we understand? This is the angle we have. We've marked it, and we've removed our protractor after taking the base, after taking the straight line, marking it at 110 degrees. We have this angle. So I hope you understand how to construct an angle or to measure an angle using a protractor. Okay, now we're going to take some evaluations to find out if we've understood all that we have learned now. Number one says change the following angles to degrees and decimals of a degree. We have 35 degrees, 42 minutes. We have to change that to decimals of a degree. We have to change 102 degrees, 38 minutes to decimals of a degree. Number two says we should find the following. Okay, this is addition and subtraction of decimals of degrees, minutes, and seconds. We're asked to add 15 degrees, 48 minutes, and 50 seconds to 7 degrees, 39 minutes, and 42 seconds. And we're asked to subtract 120 degrees, 58 minutes, and 38 seconds from 165 degrees, 54 minutes, and 27 seconds. Number three says we should state which angles are acute, obtuse, or reflexes, or reflex angles. Rather, number three says state which angles are acute, obtuse, or reflex. So we have about 4 angles here. We have to state which ones are obtuse, acute, or reflex. Now we have, in number 4, we have diagrams. Okay, we have diagrams of angles here, and we are asked to do the same. We are asked to state which of them are acute, obtuse, reflex, or right angles. Okay, now the last one here, the last evaluation we'll take today says we should write down the sizes of these angles. Okay, we have some angles here and a protractor on it, so you can easily count. All right, so we are asked to state the sizes, write down the sizes of these angles. I'm going to give us a few minutes to do these evaluations. Now, solution. The first one, we are asked to convert these to decimals of degrees. So like we learned, we are just going to divide 1 over 60. You know, 60 minutes will give us 1 degree. So we're going to divide, to get 42 minutes, we're going to divide it by 60. And we have 0.7 degrees. So in essence, okay, 35 degrees, 42 minutes is equals to 35.7 degrees. It's a very, very easy calculation. I hope you got that. Now, the second one, we have to do the same. We're going to use the shorter method here. We are just going to convert 102 degrees, 38 minutes to decimals of a degree. So when we do that, we're going to just divide 38 over 60 here, as you can see, because 60 minutes will give us 1 degree. So 38 minutes will be 38 over 60, okay, and and when we do the sum, we're going to get 102.63 degrees. 102.63 degrees. I hope we got that correctly. Quickly, number 2, we are asked to add 15 degrees, 48 minutes, and 50 seconds to 7 degrees, 39 minutes, and 42 seconds. Okay, now when we added these two, we have 92 seconds, and we can't write it down, so we're just going to subtract 60 from 92, which will give us 32 seconds. All right, now because we have a remainder, we have 1 minute remainder, we're going to take it to the minutes column. Now when we add it to that, we're going to get 88 minutes. Okay, now we can't also write it down because 60 minutes is 1 degree. So we're going to subtract 60 from 88, which will give us 28 minutes. Okay, give us 28 minutes, give us 1 degree, 28 minutes. So we're just going to write the 28 minutes here, and we're going to take the 1 degree to the degrees column. Now when we add it, 1 degree plus 15 degrees plus 7 degrees, we're going to have 23 degrees. So the sum of this addition is 23 degrees, 28 minutes, and 32 seconds. If you got that correct, please put your hands together for yourself. Now, we're going to subtract this from this. Okay? Now, the first seconds column, we can't subtract 38 from 27. So we're going to borrow 1 from the minutes column. Remember that 1 minute is 60 seconds. So we're just going to add it. We're going to add 60 seconds, which we've borrowed from here, to 27. It will give us 87. Okay, 27 seconds plus 60 seconds gave us 87 seconds. Now we can subtract our 38 from it. 38 subtracted from 87 will give us 49 seconds. Now remember that we've subtracted 1 minute or 60 seconds from this. We're going to have 53 minutes left. All right, now 53 minutes minus 58 minutes is also not possible, so we're just going to borrow 1 degree or 60 minutes from this. Remember, like we've always said, like I've been saying, 1 degree is equal to 60 minutes. So when you subtract that, we are going to add the 60 which we've gotten from here to 53, okay, which is left from here. Now when you do the sum, you get 103 minutes. Now we can do our subtraction. All right, now 58 from 103 minutes will give us 55 minutes, hence our 55 minutes here. Now we're left with 164 degrees because of the subtraction from here. Now when we do the subtraction, when we subtract 120 degrees from 165 degrees, we have 44 degrees. So the answer to this question is 44 degrees, 55 minutes, and 49 seconds. If you got that correct, please put your hands together for yourself. Now we're asked to state which of these angles are reflexes or acute or obtuse angles. So 239 degrees, of course, is a reflex angle, okay, and we know the reason why. Now 2 degrees is an acute angle because it is not up to 90 degrees. 101 degrees is an obtuse angle. 357 degrees is also a reflex angle because it is not up to 360 degrees, but it is greater than 180 degrees. Now we also asked to state which of the angles that was drawn in this diagram, this one, we're asked to state which of them were obtuse, reflex, or acute angles. Now this is our answer. This is our answer. X is an acute angle, E is a reflex angle, M is an acute angle, that's for the last one, Q is a reflex angle, and T is also an acute angle. Now for the last question, we had some angles with a protractor over them. We're asked to state and read their angles. So for the first one, we had 125 degrees, second one we have 87 degrees, and the third one we had 75 degrees. Let's quickly go back to look at them. Okay, 125 degrees, we read anti-clockwise, okay, we read the inside scale to anti-clockwise rotation. We have 125 degrees. Here we have 97 degrees, and here we have 75 degrees. So if you got that correct, please clap for yourself. We have come to the end of our lesson for today. See you in my next class. Thank you.